right? Okay, this is the assignment right here. I have it. So the last class on Tuesday, we solved this problem. So the idea was to use basic trigonometric identities to prove these other identities. So we did these ones, right? We solved these ones. Now we're going to solve these next four only. Then you're going to have the homework that is right here also. Let me just show you. This is the homework. So you have 8 problems also. Well, you have a little bit more. You have 12, right? You have more. Well, this is the homework that is going to be the grade for this week. I hope you can turn it in during the weekend, okay? But in case you need some help, you can send me a reminder tomorrow and I can open a session to explain something quickly. Okay, let's go back to this one, right? So it's problem 7 in our assignment. So we have to prove that these quotients, 1 over tangent x plus 1 over cotangent x, is tangent x plus cotangent x, right? This is okay. Let's see, this is stop right here. So here is the identity we have to prove. 1 plus 1 over tangent plus 1 over cotangent is tangent plus cotangent. This is a very strange, but well, is what we have to prove. Okay, how can we prove this one? This is well. Usually we take the most difficult to the simpler one. So this is the difficult one because you have fractions. So we try to simplify these fractions to find something like this. So how do we simplify a fraction? Okay, let's remember basic math. 1/2 plus 1/3. Everybody remember that you have to do the common denominator. So 2 times 3, right? Let me just put it here. 2 times 3 is 6. So you multiply 1 times 2 times 3. And the 1/3 you multiply times 2 is what we do, correct? Then you have 3 over 6 plus 2 over 6. And then you get the common denominator, right? 3 plus 2 over 6. And then that's your answer, correct? 5, 6. Well, we have to do exactly the same here. We are going to try to do that. Okay, let's see. We have, okay, 1 times cotangent x, right, over tangent x times cotangent x, correct? Plus 1 over 1 times tangent x over cotangent x times tangent x, correct? So I'm going to do exactly what I did here in this problem. So I multiply the first fraction by cotangents, and I multiply the second fraction by tangents. So exactly as here in these ones. Okay, now this is going to be, well, cotangent times 1 is cotangent, so cotangent. Tangent times 1 is tangent, so I'm going to have cotangent plus tangent, same as I have this one right here, right? Over cotangent x times tangent x, right? So it's what I have. Okay, well, it seems that I didn't get too much, but I'm going to check my all identities, these ones. Remember, these are the definitions. And I see that sine is 1 over cosecant, cosine is 1 over secant. And I see that tangent is the reciprocal of the cotangent. You see, the cotangent is the reciprocal of the tangent. So if you multiply these two, what you get? 1, right? So tangent is 1 over cotangent. So cotangent times tangent is 1. So this is a 1. So this is cotangent x plus tangent x over 1, right? And a number divided by 1 is the same number, so I have cotangent x plus tangent x. So it's exactly what you have to prove, right? Everybody? Now, check this out. What you need? Your basic algebra. Again, this you learn in what? In 6th grade, 4th grade, 5th grade? Years ago, you learned how to do these fractions. Well, these two numbers that look horrible are like these two. So these have to be added as you did this one. So is exactly what I did. So once I put the fraction together, like here, right? Well, I just remember that cotangent and tangent are reciprocal, so the product is 1. So I get the identity I need. So I prove what I was required to prove. Questions? No? Easy? Yes, it's easy. This class is easy. Okay, let me just check the next problem. Okay, so the next problem right here, it looks also bad. Oh my God. Fractions with tricks. This is a torture. Okay, let's see. Is cosine theta over 1 plus sine theta. And this has to be twice the secant of theta. I have to prove this identity. There is my identity, yeah. Looks bad because this, oh my gosh. This is terrible, but okay. Remember the trick, because this is the difficult part and these are fractions. We are going to begin from left and we are going to try to find the right expression, this one. Okay, now what I did before, fractions. So this is cosine, this is sine. So I need to find a common denominator. So if you remember the previous fraction, so what we did, we took the first fraction, and you multiply times the second one, right? The second denominator. So you multiply these two by this one at the bottom, plus the next fraction, cosine theta over 1 plus sine theta, times this denominator, cosine theta, correct? There it is. So it's a fraction, so I have to do the common denominator, same as I did in fractions. Okay, now, let's just do the multiplications. This times this, so this is going to be common denominator, so I'm going to put here cosine theta 1 plus sine theta. So this times this is right here, so this is the same, so I put a common line. And here, you see, is, let me see, 1 plus sine theta square plus this times this is cosine theta square. Oh, gosh, well, doesn't look better than I would like to, but let's try this one. Okay. Remember this expansion? Remember what a plus b was? A plus b squared? It was the first one squared, the double product of the terms by plus the last one squared. This is this one right here. So this here is going to be the expansion for this one. So I'm going to expand this parenthesis using this one. So I have 1 squared, well, 1 squared is 1, plus 2 sine times 1, plus sine squared plus cosine squared, correct? You see that? Right here, okay? Right there. Okay, now over, obviously, cosine theta times 1 plus sine theta, correct? So that's my denominator, doesn't change. Okay, now, something to simplify at the top. Well, I have to remember my best identities, these ones. Sine squared plus cosine squared equals 1, secant squared minus tangent squared equals 1, cosecant squared minus cotangent squared equals 1. Now, this one is right here, you see? So I can change this by 1. So I'm going to put equals 1 plus 2 sine theta plus 1, because this cosine squared plus sine squared is 1, over cosine theta 1 plus sine theta. Okay. $1 million question. How much is 1 plus 1? 2. Okay, right, 2.
I don't know.
2 plus 2 sine theta over cosine theta, 1 plus sine theta. Correct? Okay. Okay, now you see here a 2 is a common factor. So what I'm going to do is factor the 2. 2 times 1 plus sine theta over cosine theta, 1 plus sine theta. Okay, now, something to simplify over there? Something you can cancel out? 1 plus sine theta, this 2, correct? So this is 2 over cosine theta. Okay. Now, again, my identities. What is 1 over cosine? 1 over cosine is secant. So this is going to be 2 secant theta. And I prove what I was required to prove. That those two fractions is twice the secant of theta. Okay? Yeah, this looks terrible, right? But it's not that bad. It's basic math. Fractions. You do here what you did with your fractions. Then you remember some algebra. To expand something like this. Once you expand, you remember your trigonometry. This is a 1. Then you put the 1. 1 plus 1 is 2. You have a 2 here, a 2 here. You factor the 2. You have 1 plus sine. Cancel with this one. 2 over cosine. 2 secant theta. It's not very difficult. Really. Okay. One more problem.
I fixed.
Right there. Okay. Now, this one, yeah, looks also bad because you have fractions. Oh, don't panic.
They all have
Fractions. Of course, you are in pre-AP. You are my best students, the most intelligent. And really, these problems are easier than the cheerleaders tryouts, the baseball tryouts, and the choir. This is easier than that.
You sure?
Yeah, of course. This is easier than do the things you do in cheerleading.
Not cheerleader.
Yeah, but Stephanie is a cheerleader.
I'm
and
a
in
dancer.
baseball, there is no problem. They are going to hit you with a ball, right? Right here. This is safer. Okay. We have this fraction. Okay, this fraction at the left, this one, right? This fraction at the left looks worse than this one at the right. So we're going to do this fraction right here, correct? Now, check what we have to find. Only sines and cosines, you see? Sines and cosines. And I have here a tangent. So I'm going to change this tangent first, correct? So what is the tangent equals to? Okay, let me see. Tangent is sine over cosine, you see? So I'm going to change the tangent by sine over cosine. So I have cosine x minus cosine x over 1 minus sine x over cosine x. Okay? This one. Okay, now I have this fraction that is a complex fraction, so but not problem. I focus on this one. How do I solve this one? With the common denominator. So this is going to be cosine x, I don't touch this one yet, minus, I don't touch the top one yet. I'm going to do this fraction. So this is cosine x over cosine x minus sine x over cosine x, correct? So what I did, I changed the 1 by this one. 1 is cosine over cosine. This is a 1. Now I have a common denominator, so I can put this together. So this is going to be, okay, I copy the first term, the cosine x, minus, I copy the top one, cosine x. Well, let me just wait here. This is sine x minus sine x over cosine x, correct? And I'm going to write the top one as a fraction. Cosine x is cosine x over 1, you see? Why? Because I have a fraction and I solve a fraction over a fraction with the sandwich rule. Remember, the sandwich rule, this times this at the top, this times this in the denominator. So I have cosine x, so I pass this one again here, and then minus my fraction is going to be cosine times cosine is cosine squared, correct? And 1 times cosine x minus sine x, right? Is like that. So this fraction now is only this fraction. So with the sandwich rule. Remember, everybody knows the sandwich rule. We have been doing the sandwich rule since the beginning of the course. Okay, now I have to do this fraction now. I have to put a common denominator for this one. Remember, this is cosine over 1. So I multiply this times this denominator and the 1 times this denominator. So I'm going to put it like that. Cosine x times cosine x minus sine x over cosine x minus sine x minus cosine squared x over cosine x minus sine x. So what I did, common denominator, multiply top and bottom by cosine minus sine x. Now I put it together. Big line. Cosine times cosine, cosine squared x. Cosine times sine, negative sine x, cosine x. And now this together minus cosine squared x. And at the bottom, cosine x minus sine x. Yeah, this is a big line. Yep. Okay. Now, can you simplify something now? What's the expression? What you can simplify? Nothing here. What about here at the top? The cosine square minus cosine square, they cancel out. You see cosine square minus cosine square, these two cancel. So cancel these two. And then I have negative sine x times cosine x over cosine x minus sine x. Correct? And it's exactly what you want to prove. This expression is this one. I guess I copy down only a symbol right here. Here is what I have. Correct? Everybody? So you see, algebra 1, algebra 2, with trigonometry, everything mix like a shake that you have to drink. Okay? No questions in this part? Bethany, Stephanie, Alex?
No.
Told you, this is easier than cheerleading and baseball and the choir. This is easier.
It's easier than choir. Choir is easy and fun.
Okay, the last problem. Okay. The last problem is going to give us a little bit trouble, right? Let me just write it. Is the square root. I'll use another marker now. Okay. The square root of 1 plus sine theta over 1 minus sine theta, right? Equals 1 plus cosine theta over absolute value of cosine theta. Okay. Well, this looks terrible, right? Yeah. You have square roots, you have fractions, you have absolute values, all your nightmares together, right? Okay, no problem. I want to recall something. Do you remember when you have 1 over the square root of 3, what you have to do? A square root in the denominator was not the standard, so what you used to do? You took the square root of 3 and then you multiply by 1. But the 1 has to be the same as in the denominator. So you have a square root of 3 times a square root of 3, correct? Yep. Time equals is going to be a square root of 3 over 3, correct? 1 times the square root of 3, square root of 3, square root of 3 times square root of 3. squared, they cancel and you get a 3. You remember this? Yep. Okay. Something else I want you to remember. If you multiply a plus b or a minus b times a plus b, what you get? A squared minus b squared. You remember that? Yep. It's basic algebra, correct? This was in algebra 2. You did this in algebra 2. This is basic algebra. So this is what I'm going to use right here, correct? Is what I'm going to do right here. So what is what I'm going to do? So I'm going to use this one. The fact that 1 minus sine square equals cosine square, right? This is something I'm going to use. So this is 1 square minus sine square equals cosine square. So I'm going to multiply by this expression to get something like this and simplify the square root. So this is what is going to happen. So I'm going to have a square root of 1 plus sine theta over a square root of 1 minus sine theta. Why I can do this? Because I forgot to do this one with you. A square root of a over b is the square root of a over the square root of b. Another algebra 1 thing. So I'm going to do this. I had all the square root in the fraction. So I split my square root and then I'm going to multiply times the square root of 1 plus sine theta. And at the top, I want to use the same sine theta, correct? So everybody catch what happens? So I split this root into these two. Then I'm going to multiply this times this root. So if I multiply the denominator by this, I have to multiply the numerator by that. Okay, well, let's do the thing. So this is going to be 1 plus sine theta, a square root of 1 plus sine theta square, because you have the same thing here. So this times this is this square, over, I'm going to put the square root of 1 minus sine squared theta. Why? Because if you multiply the same thing with different signs, you get the difference of the squares. So this is 1 squared minus sine squared. Okay? Now, I'm going to use my trigonometry now. Sine squared plus cosine squared is 1. So 1 minus sine squared is cosine squared. So I'm going to change this by cosine squared. So this is going to be, in the denominator, cosine square of theta square root, correct? And what happened at the top? I'm squaring the square root. So what I have? 1 plus sine, because these cancel out. So I have 1 plus sine theta, correct? Okay, now, algebra 1 again. Ready for algebra 1? Okay. Do you remember the graph of this function? You remember this graph?
It's a V.
Hmm?
It's a V.
It's the B, correct. Very good, it's the B, correct? Now, I want you guess what is going to be the graph of this one.
What?
Yes, what is the graph of this?
Isn't it like?
Well, don't guess. Let me just use the calculator. Let me just share the calculator with you right here. And then I put a graph, and then I'm going to do this. So the square root of x squared. You see? The square root of x squared. What do you think you are going to see? A line? Well, let's see. The B. Exactly. Okay, a ver. Why I'm doing this? let me just stop share here. So I asked you, what is the graph of the absolute value of x? Well, you learned that that's the v. Remember this graph? Yeah, it's very used. The absolute value of the x is the v. Now my question is, what is the square root of x squared? What is the graph of this thing? You were guessing, well, this cancels out, so has to be the x, a line. Well, let me just use the calculator. The calculator is not going to lie. The calculator, oh, let me just go here, share again the screen. Okay, so share again the screen right here. So share the screen, the calculator, and then you see that. You plot the square root of x squared, and you saw the same v. There is no way out. The square root of x squared is the same as the absolute value of x. So what is going to happen here? Well, this is the square root of the square, so this is going to be 1 plus sine theta over the absolute value of cosine theta. And that is what you want to prove, that this radical with this quotient simplifies to this fraction. You see what I have to use? Algebra 2, algebra 1, trigonometry, and then I use the thing, multiply times this negative, positive to get this one. Once I have this one, I use trigonometry, change by this one. This square root is square. And at the end, I get this is the absolute value of the cosine. Because that, the absolute value of the function is the square root of x squared. Correct? Well, any question? Something, complain? No? Piece of cake, told you. It's easier than the
Very
tryout.
easy.
Right, Stephanie? The tryouts are difficult, right?
Yeah, push-ups, ready.
Okay.